So for now, we have little time, and I mean for now. So we are going to have to decide what to do. And for now, it's better we do space and things like that than anything else. I don't know if you agree. So what I will do is, because you can look at this reference, and then, as you know, there's this tool, the Wiki, that Matteo and others have been worked hard to try to develop these things in detail. I invite everybody interested to go there and to send feedback on that and to improve on that. So I will leave that out. I will just very quickly say some things about what I normally say in a lecture. So, which is IIT actually, for many, many years, has tried to take these fundamental principles and see if these are roughly right, then can we test and validate the theory in the only place where you can really do that, which is on ourselves. And basically explain these things we have known for a long time, but people haven't really bothered about. Why some parts of the brain are important, others are not. If IIT is right, can we understand that? Okay, this is from first principles. So this is not saying, oh, my experiments show that there is gamma activity here when you see something and not when you don't. So I have a theory of consciousness that says it's gamma activity. No, it's if consciousness has those properties, and those in physical terms require a substrate that is maximally reducible and so on and so forth, is that true, and can we explain basic stuff about the brain when you lose it and when you don't? And so again, I'll be super fast, but you can then go back and see what do we know and figure out whether the parts of the brain that empirically seem to be important for being conscious are the ones that satisfy the requirements of IIT that we just saw, and the ones that have nothing to do with consciousness, even though they are part of the brain and are very complicated, have even more neurons, don't have anything to do with it. And that's the example I always use is the cerebral cortex, this part of it, are critical. Everything we know suggests that without that, you're not conscious, or you lose pieces of consciousness, you lose pieces of cortex. But if you go to the cerebellum, which has 4 times more neurons, you can take them all out, and your consciousness doesn't change at all in any direct manner. So you need to explain that. IIT explains that and says the cerebellum has the wrong anatomy. It's modular. That's terrible because you don't get integration. Phi is 0 or very, very low. Okay, so it explains these basic things. And then the other thing we worked forever to demonstrate is the most obvious way in which consciousness changes in all of us is when we lose it, when we fall into dreamless sleep, and then it comes back, even if we are not doing anything when you're dreaming. And so we did lots of experiments to check what happens when you lose it and you get it back. And the idea is that even if your substrate is right, is cortex, if the ability of this subset of cortex to interact is broken because of the bistability that's due to GABAergic cells blocking the interaction among neurons, we know all the details, we can talk about that, then you lose consciousness, even if your anatomy is right, the physiology is wrong, okay? And so that fits, and with intracranial recordings, you can show that when you lose consciousness, it's because in the right parts of the brain, the causal interactions are impaired. So there are many, many things to say about that. But the one, because of the t-shirt that we are going to try to focus on, is what is the fundamental sort of research program. Let's just say that IIT so far holds up under these basic tests of what is the right substrate and what is not, why do you lose it in sleep and wake, which is nothing, something you can say of any other approach really like that. And even developing clinical tools for that, all that we can leave it maybe for later if you're interested. And it makes counterintuitive prediction, like you can be conscious with minimal neural activity and so on. So all lots of interesting things. But the bulk of the research program has been for a while, it's just a bit hard, to explain not only whether consciousness is present or absent, and what is the substrate for it, but why does it feel the way it does? Okay, so, and that is basically the whole idea of this school. And I must say at the outset, I probably will say that also next week, that trying to understand the quality of consciousness, understanding the quality structure, is still a completely foreign notion to most people that study it, with very few exceptions, now being one. Okay, really, I mean, now how many people are there really who see that as a fundamental research program that you need to explain it? And so I like to say it's physics, not magic, okay? When you have the hard problem of consciousness, oh, we don't understand why the sunset looks so beautiful and so on, and you present it in those ways, or pain feels so painful, you'll never understand that because you'll never find, as Leibniz said, in the brain anything but mechanism doing their stuff and performing functions, and yet pain is painful. When people say that, generally speaking, they have not the slightest idea about how you would even go about it. It's not just that the hard problem seems to be incommensurable, it's a different thing, is an explanatory gap. It is that why would it feel the way it does seems to be inconceivable. You can't really know what would I use to figure out why pain feels painful. I mean, what do I do? Is it like I'm going to find an intrinsic property of some neuron, that's the pain neuron, because it's sort of a burning kind of neuron? I don't know what, okay? So people have no idea how to go with that. But the moment you begin to realize that what makes an experience what it is the way it's structured, then suddenly you can perhaps get an insight and work out in principle why it feels the way it does, and making it a topic for physics and mathematics, fundamentally ultimate mathematics, rather than something utterly mysterious, inexplicable, incommensurable, what we do in neuroscience. Okay. So the strategy we followed, very, very consciously so from the start, was to begin with those properties of experience that are more accessible to introspection. So where you can reveal some of the structure of experience through introspection, which is our starting point. When we went through the axioms of IIT, the properties that are true of every conceivable experience, we used introspection to say every experience will not only exist, it exists for itself in a specific, unitary, definite, and structured way. And now what we want to ask is, well, let's talk about the structure. Can we say something about some aspect of experience that are amenable to introspection? And so the first one that we focused on quite a long time ago was the experience of, let's say, space. More specifically, we use visual space, but it could also be body space. Because of two things we always say. One is they are pervasive, so most of our experiences are, so to speak, painted on the canvas of visual space. And the other one is because it's penetrable, meaning you can, using introspection, say something about the structure of space. Okay? And the research program goes as follows. First, let's try to explain why space feels the way it does. And that's what we're going to talk about, because that's the part that is published quite some time ago, and it's more directly amenable to experimental validation. And then the program goes with time. So why does time feel the way it does? That is flowing. You'll feel that it is flowing. And the next project, which has been going on, but it's not finished by any means, is about objects. Why do objects like faces feel the way they do? Okay. I think all of this is programmatically achievable, starting with what's sort of easier and more directly introspectable, and then progressing by extrapolation to what seems to be not to knack, which is, for instance, pain or timber and so on. So that's the research program, and I think that's very much fits also with what your research program is. But we are trying to do this from first principles with no additional ingredients, and ultimately in a way that's testable on our own brain. Okay. Something like that. That's the goal. So you can see here sort of the research program starting with space, time, objects, and then what we call sometimes local qualities, for lack of a better term. Okay. All of which we think will be explainable ultimately based on anatomy and physiology, primarily anatomy. So since I didn't really know what would happen today, let me just see if I can find I don't know if I have it. I hope I do. Let me see if I find it. This is stuff that we might want to use. So it's too complicated to find it. So I'll say it and then we'll find the slide. The idea ultimately is that experience of space, and that's what we're going to discuss in more detail, is going to be accounted for by unfolding a particular kind of anatomy. That is a dense lattice. Okay? Non-directed dense lattice. Basically like the kind of grids that you find in areas like B1, B2, B3, B4, and all those areas in posterior cortex. So if you have a lattice like that, with neurons that interact laterally and then also areas stacked on top of each other, you unfold that using the principle I showed you this morning. And what you would get is a cause-effect structure that should account for why space feels extended. That's the claim there. Conversely, the substrate for experiences of time, the fact that experience is flowing in time, like what I'm saying now, flows in your consciousness, you can contain within your presence a second or so of words that together coexist in your mind, okay? The beginning and the end of the sentence, something like that. That will have a substrate which is a directed grid rather than non-directed. And we have some suspicions where you will find them in the brain. Then we'll come to objects. And for objects, we think the key thing is that they bind the general with the particular, a general concept with sets of particular features. We call these things conceptual hierarchies. And we suspect that the substrate for that are these pyramidal organizations that you find throughout posterior cortex. And finally, we think that for the local qualities like colors and sound and things like that, the anatomical substrate is a different kind of graph, not non-directed grids, not directed grids, not pyramids, but rather local cliques. Okay? Cliques of all-to-all connected neurons, connected in different ways in visual cortex, somatosensory cortex, and different places in the brain. So take these different anatomical substrates, make sure they are physiologically in good order, put in some extra physiology, and then unfold it. The claim is, if you have this kind of lattice, it will feel spatial. If you claim this kind of directed grid, it will feel temporal flow. If you have this kind of hierarchy in a pyramid, it will feel like an object binding the concept of a particular feature. If you have these local clicks repeated at every place in the grid, for instance, you will have colors that will color a particular position in space. And then there are going to be crazily complicated binding, meaning relations among all of these things that end up forming this kind of space in which we live, flowing in time with objects in it and thoughts and so on and so forth. So this is just to give you, I haven't explained anything, but ultimately the idea is give me the graph, the causal graph, the lattice, and some physiology, unfolding with no other ingredients than the postulates. And we should be able to account for why space feels extended, time feels flowing, objects feel like binding the general with the particular, and local qualities feel colored or sounding, and so on and so forth. And then much more complicated things will follow. But the beginning is starting with what's easy. Now, easier is a funny thing here, because we chose space, and this is work done primarily with Andrew Howe. He was not here, but he was a postdoc or student, wasn't he? Basically whatever with now, okay, is the idea that we want to explain why, say, this screen feels extended, spatially extended. Of course, it's not just the screen, it's the entire visual field. And of course, it doesn't even have to be visual. Your body feels extended too, in a different way, but it's extended in a more complicated fractal manner. So why does it feel extended? Funny is people with minimal exceptions have never asked this question. It's almost unbelievable for me, okay, because you go through the history of philosophy, etc., and not natural science, and people haven't asked it. They have taken it for granted. You know, space is space because it's out there and we represent it, or whatever word they use, they don't see a problem. And instead, the first claim we make in the paper is that explaining why most of your experiences feel extended they, so to speak, are painted on the canvas of space, visual say, or burnt on the canvas of body space, or itching, if you have that, on the canvas of body space, that question is very much the same question that we ask about why does blue feel blue? And it seems impossible to answer, why it's blue, what makes it blue. So what makes it extended is just more penetrable, because while we cannot extract any structure about blue, blue feels blue, period. There's nothing else I can say about it, really, except how it differs from other colors, and we'll get there at some point. But about blue itself, I mean, at most I can say it has hue, saturation, and brightness. But beyond that, I really have little to say. But for space, it's the easiest thing in the world to begin to say, oh, look at the spot here, a spot there, and the distance among the spots, and the spots overlap with that spot. We can do all these things as if it were nothing. That's the difference. But in terms of feeling, it feels just as much as a color. It's just that people take that for granted. They don't see that it's something to be explained, but it is just as much a problem of consciousness as the one for blue. That's we call that the first problem of space. So paradoxically, this one that one should start from is not even considered part of the mind-body problem, or it's a representation. And the second problem, and we'll probably get to that, is that even if you, let's say, realize that, oh yeah, there is something to be said about why does space feel extended, William James did at least realize there was a problem. And before him, since Alex gave me very kindly a translation this morning of Fechner, study of psychophysics, etc., which has some wonderful ideas in it, he there quotes Lotze. Lotze was a German philosopher, psychologist, physiologist, you name it. But those were the good days in which they were doing everything. And Lotze was the other guy who actually realized that you had to somehow explain this. He didn't provide an explanation, but he realized that. But with those exceptions sort of lost in the history, nobody has really worried about that. But even if you were to see that, like James, okay, what is typically also not seen is what it takes for space to feel extended, and what it takes is an immensely rich phenomenal structure. We call that the second problem space. So let's now try to briefly do this phenomenological analysis of what it takes for space to feel extended, and then see how we can potentially account for it. So last time we did that, it was Matteo and I in Tucson, not long ago. And Matteo gave what we have now here, so we can decide whether to do that. And the big problem, as Matteo knows, of doing this is that we look like complete idiots in explaining this. Because we're going to tell people something really profound. And it's the most idiotic thing in the world. We will now show. That's, in fact, why it is profound, because it sounds idiotic. Okay? And it's all sort of the signature of IIT, as you know, would be a T-shirt without the Q, just black, and very big, and all enveloping. Okay, one that would do that, and you look at the blank screen or a black screen or a black sky. That is, if you get that, you get IIT. Once you understand what it takes for you to see a black screen, to see a black sky, and I mean it. Okay, if you understand that, we are in a good spot. So the idiotic argument we make is starting by saying, look at the screen. Let's use this as if it were the entire sky and you're lying on the beach and seeing the dark sky. But we want to point out that there is something it is like to experience space, regardless of other things. So the first thing that we can say, regardless of, is colors. So, the sky could be dark, or the screen could be dark, or it could be red, or it could be blue, or it could be green, or it could be anything. Okay, it's still extended. You know what I mean? Regardless of the color. So we are not trying to account for why it feels red. We're trying to account for why it feels extended, regardless of the color. Okay. Of course, it could also contain, objects, faces or things moving, all kind of other stuff. But that's what space does. If you go around here, you can see all kind of things, always in space. So again, we want to understand why it feels extended, regardless of what object you might point out within the space. They always are somewhere in the space. That's the obvious thing to realize. But it still feels extended. And then, that's where the really stupid part starts. Can I leave it to you, man? But the important thing is not that, is to say that it's really stupid what you're going to do. But you want the microphone? Oh, you can just. Oh, yeah, I can give it to you.
Well, we're all in luck because it's never been a problem for me looking like an idiot, so I'm comfortable. Should I go ahead? Is it still good? Yeah, it's better. At least it seems to be gone. Okay. Is it okay? Can you hear me okay? Yeah, I can speak louder, closer. Okay. So we are trying to showcase the fact that experiencing space, in particular that space feels extended, is a very important thing to do. Because, like Giulio said, space is pervasive, but on top of that, space is as qualitative as color and taste and pain. And to me, just to add something on what Giulio said, if I wanted to explain taste in full, of course I should explain sweetness and sourness and all its properties, right? Just like to explain my experience, my visual experience in full, I have to explain color and I have to explain shapes and that I see faces. But I also have to explain that my visual experience feels extended. And that's not something that I find when I try to explain my gustatory experience. So that is a key feature of my visual experience that needs to be addressed. So there are, in the attempt to introspect the essential properties of visual experience, in particular the influence of space and why it feels extended, there are really some things we have to start from. And one is that it has, in order for space to feel extended, I must be experiencing spots, some components that, for the lack of a better term, we just call spots. And just to show somehow with a graphical representation what we mean, well, this is a spot, right? You are seeing a bright spot on the screen and the spot is there. There's a portion of space that is highlighted. But of course, what we want to make you realize, which is trivial, is that now that the spot has gone dark, the spot is still there. You're still seeing space on the screen, right? Before it was bright, now it's dark. And of course, you can see another spot. It's bright, it's big, and now it's gone dark, but it's still there. You are seeing a lot of spots actually right now. Some of them are small and big. Some of them are bright. Now those ones are gone dark, but you're still seeing a lot of spots. They're all on the screen. They're just dark. It does feel stupid, but it is not. Because if you think about that, this is really a key feature of space and why it feels extended. And again, just as an intuition pump, so bear with us, we can try to explain what happens if the spots that compose a region of space weren't there. Like in this case, we have highlighted some of the dark spots that are composing this central region of space between these two bright spots, and they're all there, right? So we can ask the question, what happens if we were to remove all the spots from that central region? Well, the idea is that if you remove all the spots, then clearly that can't be any space left in between those two bright spots to separate them, right? Of course, I can't do this because I can't talk and alter your perception of space and act on your visual cortex, but I can represent this by shrinking the space and just removing some of the dark regions to show that the space in between is gone. So first message really that we want to highlight is that in order to experience space, you need to experience spots, and a lot of them. And the experience of space, of course, is spots, but these spots need to be related to each other. They need to be related, in fact, in just the right ways. And I point you back to the space paper because that does a much better job than I can do to articulate exactly what the essential properties of space are and the relations that are necessary for you to experience space. But I'm just going to show briefly to walk you through them. The first property is reflexivity. So spots point to themselves. They don't point anywhere else. Just, for instance, like instead moments do. When we experience a moment, it kind of flows away from us, whereas like spots are always there in front of us, so to speak. The second property is that it's called inclusion. So it is always true that for a spot, there must be spots that include it. And this is, if you think about it, it must be true. Otherwise, how can I experience a spot that is part of space if there is no spot that includes it? This spot would be the whole space if no spot included it, right? But it's also true that spots always include smaller spots. And this is also true intuitively because counterfactually, if a spot didn't include other spots, I wouldn't be able to see it as a spot extended occupying a region. It would just be a non-extended point. And the following property, so this was inclusion, and then we have connection. So it's always true that spots partially overlap other spots, and they have relations that allow them to be at a specific distance, neighboring with some other spots, have an ordering in the space. And finally, the last property is fusion. So it is always true that if two spots, if two spots overlap, then their union is also a spot. So this characterization is important because it highlights, so this is fusion, sorry. This characterization is important because by highlighting these four essential properties of space, we can then attempt to explain the experience of space and see whether a lot of other derived properties follow. Just to recapitulate what we just said, there are important features of spatial experience are that there must be spots, and a lot of them, and we've seen what happens when we remove the spots, the space just disappears. And what's true for a region of space is also true for space as a whole. And then that the spots that are there must be related just in the right ways, right? And again, another sort of like embarrassing way to show it, because it's very hard to do it on the screen, is that if I now consider that all the spots that compose the white region are there and are related in just the right ways, if I ask the question, well, what happens if I unrelate them? Well, one,
because it's a natural water in which we swim as fish, okay? So we don't realize that it is the fabric of our experience, of our conscience every day, is actually a piece of experience, because that's what it is. And I would bet that it started by people drawing Venn diagrams in the sand and saying, no, this is mine, this is yours, and this we share, or whatever, things like that. Because visual attention, after all, is so malleable. It's what we use for introspecting spots and how they overlap and so on and so forth. So it comes totally natural because our brain, the part that we think support the experience of space, which is most of consciousness, are organized in a certain way, which we'll see. So that's how most experiences are. They are organizing according to those principles. And our conjecture is that in the 18th century and 19th century, when mathematics starts growing, etc., and people came up with set theory and then refined it, abstracted away, and then topology and so on, they took what is a shared feature of the most basic kind of experiences we all have as humans, and they abstracted away beautifully and making it immensely powerful and elegant because it is abstract. But it's not, oh, this is just set theory applied to phenomenology. This is set theory comes from phenomenology in a way, but it's something to discuss, which is why I like the fact that you put it in the positive. Okay, so absolutely like that. So good.
Yeah, so I don't know if anyone shared the same phenomenology, but I would say that when I see the black canvas, it is easier to say that I can imagine the spots rather than see them. So I was wondering whether this makes a difference for IT, because phenomenologically perception and imagination might feel different. Then the second question is why is this not an axiom if it is so pervasive? That's it.
All right, so let's start with the second question. But the second one is, and that's an important point, both space and time, especially time space, which is so pervasive, okay, is not an axiom because it is conceivable that you could have an experience which is non-spatial. So sometimes I want to say which one. I'd say imagine experience of pure smell. Okay, you could have an experience of pure smell. It's perfectly conceivable, and of course, our smell is usually located somewhere, okay? But you can still conceive of there is just an animal of pure smell, okay? And therefore, you don't have that as an axiom. But it is much easier to relate to than many other things, okay? So it's not an axiom because it's conceivable to have something that exists intrinsically, in a specific, definite way, and all that, and is not spatial, like pure smell. The second question is, and believe me, you're not the only one to have said things like that, okay? People are not used to doing that. Is that something I imagine? So was the spot there when it was dark? Yes, when you highlight it, my attention is drawn to it, I see it, and the people immediately say, oh yeah, you see it because you attend to it, so it's attention, it's not conscious. Okay? The exercise here, and that's what's tough about it, is to understand that if you didn't have the spots, so Matteo showed it with okay. If they weren't there, you wouldn't be able to see the dark region between the two bright spots. So evidently, they had to be there in order for you to perceive the two bright spots at the distance they are. Okay. You don't have to go and sequentially highlight every spot. By the way, they don't need to be over. That was just a way, because our attention works like that. The point to realize it is that there must be all the spots in between related in a certain way for you to be able to see. Okay. And so and that's why it is so hard, okay, and that's especially the richness of it. Especially when it comes to people saying, but wait a second, can't you just say XY coordinates if we go too deep, okay? And XY coordinates, you give me pairs of numbers and that's all we need. I can build a machine, I can tell you the coordinates every point, that's the easiest thing in the world. For sure, that's very convenient, you can do that. But another way to put it is, we had a long discussion with this with one of the philosophical experts in space and time, I won't name the name. One thing to notice about that is if I give you two coordinates, 2 dimensions, and a pair of numbers, what makes it into a space? I mean, mathematicians can say this is space now, but would it feel like that at all? Okay, it's just a bunch of numbers, and you can use it if you know what space is already to indicate here versus there. But if you don't have any sense of here and there, what the hell makes it into the space we experience? Okay, so it's tough because it is so connaturate in our experience, okay? We don't realize that to see that dark screen, it must have all its spots, small and large, here and there, not only, but they must have all the right relations among them. This must be including that one and be included by that one and so on and so forth. It must be partially overlapping with that one and so on. It must be fusing with that other one to form another spot. So all of these things are needed. Otherwise, space wouldn't feel the way it does. And the fact that we don't realize that is because we take it for granted. Okay. So, and because space is so common, it's unlike, something like the person who tells you the way I felt, I cannot really express it in word. Or to discuss an example that comes up with Miko very often, which I like because he was in a few people who actually sort of pointed that out as being fundamental for consciousness. If you listen to, I like the Tristan chord in Wagner, something very complex sounding that you cannot express in words. It feels the way it does. People cannot put it out. It's not a functional thing, it's a phenomenal thing. You realize that there is something there that needs to be explained, but we just have no idea how to go about it. Okay. But for space, because it's so obvious and we all share it, if I say there, everybody understands there. Okay. If I say take that spot, everybody understands that. If I say these two spots overlap, everybody understands that. That's so trivial that pointing out that you see spots and they must be there, they must be related that way, is underwhelming. Okay, it's very underwhelming, except evidently not for Michael, who so that it is actually sort of an essential thing. And so not only do we see space as being a fundamental property of consciousness, most of our experiences are in space, but it's also immensely rich. So to see that black canvas, you must be seeing tons of spots, we'll get a sense in a little while, and they must be related in the right way. If they were related in a different way, it wouldn't feel like space. That's one of the things. For instance, it could feel like time or like objects, okay, depending on their related. You want to go on and show a little bit how you do that, or some other question right now? Yeah, okay.
It seems to me that there's maybe a layer of complexity missing from this phenomenology, but I'm not sure if it's actually significant. So I was introspecting while you were showing this, and I think that the phenomenology that you're describing sounds like it's dependent on perfect visual binding. But in my experience, it's not perfectly bound, and I can kind of exacerbate that by crossing my eyes. So you might have seen me crossing my eyes, which would be a bit strange. And in that sense, when you showed that slide of all the spots of space decohering, that's kind of what my experience is like when I cross my eyes. But when my eyes are uncrossed, there's still some level of that left. It's not perfect binding. Another example would be under a moderate dose of ketamine, where you're not disconnected from the environment. Things definitely decohere in such a way. So I guess, yeah, I'm not certain this is very significant because perhaps it's still a structured decoherence, but I wonder if it would make any difference to what you expect to see in the substrate in terms of the structure that you're.
I suspect that's a very, very good point to raise, but I suspect, if I understand what you're saying, which I think I do, that that relates to things like diplopia. You start with that, okay, whatever words we use. When there are discontinuities in the space, like contours or objects and things like that, or even bright spots in the black background, then you might have, say, a few sort of not anymore perfectly like this, they superimpose in some strange ways, we call it decohere. But my claim there would be no, the fundamental fabric of space is the same, it's just that these additional things on top of it, meaning the discontinuities, cross in an unusual way. That would be my guess, okay? And the exercise to do would be just take the perfectly blank screen and try to call it decohere if you want, decohere that. I bet you won't be able to do that, okay? It will, so in other words, there are no holes anywhere. The whole thing is going to continue to be special, but the object makes strange things on top of that, something of that sort.
I'm hoping to get some clarification on the first 2 points. So you said to experience space, we must be experiencing a lot of spots, and spatial experience is independent of whether there is sensory stimuli in the space that we're seeing. But and then in the illustration, you showed the light spot and then took it away and it became dark. And I think the illustration was that even when the light spot is gone and it's all dark, we still kind of see the spots. But I'm just wondering, should you have seen those light spots at any point to have this spatial extendedness, or is that not necessary? Because so I guess I'm wondering, does space really feel expanded without any kind of like reference point? So even in like a full pitch black dark room, we feel spatial extendedness, but we still kind of have a point of reference, which could be our proprioception maybe. And I'm just wondering, like, if that, like, where that would come into play, if it does, or if it doesn't matter, like, why would it not matter? And if you need this kind of point of reference or have had the past experiences of seeing light spots, then is it really irrespective of sensory stimuli, presence? And then if so, is it really a fundamental feature?
All right.
Yeah.
Lots of things there. But first of all, to your first question, no, you don't need to have seen the bright spot in order to experience space in one fundamental sense. In another sense, and this is something that will come up all the time, without the brain you have, which came about because of evolution, developmental history, and then training by the statistic of the world, okay, you would not be seeing space the way we see it. So you don't need to have seen the white spot in order to see that spot as a spot. But you wouldn't have the subset you have, which is this grid as we will now show, okay, that you find in much of cortex, if it weren't because you're exposed to the world that has certain statistics and the brain internalizes those statistics in its anatomy. Okay, so there is a sense in which without the world and its statistical structure and you adapting to it, you wouldn't have the kind of brain you have, and without that, you wouldn't be experiencing space. But once you have it, you can have it. Okay, you don't need to have seen the little white thing. Second thing to say is, do the experiment and close your eyes or be in total darkness or go to the restaurant where they want to shock you by showing you what it is to have dinner without any light and so on and so forth. Clearly, as you pointed out, there is still space. But an interesting question there, which is an open question, is whether it may shrink a bit or change a little bit in its nature when you actually close your eyes. And that we don't know, but because there is a lot of change in the way, for instance, the excitability of visual cortex is changed by having eyes open versus closed, etc. I think it's an interesting empirical question to see whether the fabric of space may coarsen a bit when your eyes are closed. Okay, so it's still spatial. There's no doubt it's extended, but it may literally shrink a bit. It may be that some of the peripheral part of visual cortex, in this case, may become so inexcitable that they don't contribute to some portion of space. So these are interesting empirical questions. Okay, and then finally, the last point, which I don't know whether we will get to, but is the point of reference. Okay, for sure. I mean, this of course is now phenomenology, but it strangely echoes the old diatribe between Newton and Leibniz about the nature of outside space, whether it was absolute a la Newton or relative to objects in it a la Leibniz. In this case, it's no. Is intrinsic, is absolute, but it's absolute intrinsic, not extrinsic. It's not a container. But you don't need to have any object, so it can be purely dark. But there is a sense in which we are centered in the middle of it. So that's another aspect, and that's one of the key things in the phenomenological dissection you have to make. It feels extended, but yet another thing is, well, it feels dark, for instance, that has to be explained through local qualities. But it also we feel in the middle of it. So this is what sometimes people call perspectivalness. Okay, how do you explain that? And we're not sure, but we actually think that the explanation for that is, and I'll just say it right now, that if the subtle space is, as you'll see in a moment, is presumably these dense lattices, these grids in visual cortices or somatosensory cortices, etc., stacked upon each other, there are lots of these grids that are oriented towards action, that are important for moving your eyes or moving your arm, etc., in the personal space, peripersonal space, when you can reach, and distant space where you can see. Okay, and all of these naturally put the center of action in the middle of the body, or in the cyclopean center, which is like 8 centimeters behind the eyes, back here, okay, where it's sort of like where we are looking out at the world from. And we think and IIT can potentially explain that because you have all these action-centered areas that are in register, meaning bound by physical relations to these visual areas, for instance, that they give more emphasis, they literally center the space by putting the center of action in the middle as opposed to but let's leave it up. So there is an interesting, I think actually it's an elegant explanation of why there isn't just space, but we typically feel in the middle of it. We also know that you can feel outside of it, but that's telling you it's not necessary. So these are a few things, but before we go any further, maybe Matteo,
Sure. Okay. So well, again, let's point you to the paper if you want to look at the details. So as Giulio said, the general idea here is that we want to characterize the phenomenology of space, and we've done so by saying my experience of space feels extended because I can always find these properties. Every time I focus my attention on a spot, I can always find spots that are included and that included, that partially overlapping, and that fuse with it. And we've explained this with these 4 spots on the left, bottom left side, just to show you. These are 4 spots. This, of course, applies throughout the space. The diagram on the top left just abstracts and says these spots they relate to each other and to themselves through these relations, these properties that we just explained. And the hypothesis of IIT is that, well, this must correspond. We have to find a correspondence between those properties that we find in phenomenology and the properties, in this case, of a substructure that is of a bigger cause-effect structure. This is my entire experience right now. So if I just take the spatial portion of the cause-effect structure, it's this substructure here. And of course, when we try to unfold the cause-effect structure, we can start from something that is driven by our knowledge of the brain. So in this case, we know that visual cortex contributes visual experience, in particular also spatial experiences is part of it. And we know that the architecture is a lattice of 2D grids stacked on top of each other. But the conjecture of IIT is that, well, we must be able to find a correspondence between those properties and some properties of the substructure when we unfold a substrate that is inspired to this architecture. And we wanted to go even simpler than having stacks of 2D grids with thousands and thousands of units. And if this is true, it should hold for a grid of units. We can even make it 1D, not even 2D. It can just be 8 units instead of thousands and thousands. It's a proof of concept, but it should hold. And the space paper is the attempt to do exactly that. I'm going to skip this because Giulio basically explained roughly how from a substrate model we can get a cause-effect structure. It is that we find distinctions and the way they relate. So you know roughly what this thing is. What happens when we take a grid that is inspired to the grids in visual cortex and we unfold it? So what we find is a pattern of distinctions with some causes and some effects. Here, I'm just showing some of them for this particular grid. And you can already notice that the distinctions have a pattern, like the cause, which is in red, and the effect, which is in green, are usually over the same units of the mechanism. So for instance, distinction BCDE as a cause over CD and an effect over CD. So the cause and the effect are sort of like centered. They are a subset of the elements of the mechanism, and they are the same. Cause and effect are over the same units. So the goal of IIT is that just by unfolding this grid, now we have the distinctions, we can compute the relations, and with no additional ingredients, we should be able to find some properties in this structure, cause-effect structure, that explain why space feels the way it does, meaning we should be able to map reflexivity, inclusion, connection, and fusion onto the relations that hold between the distinctions of the cause-effect structure. So this is the end of the process. I'm just showing you that just like I can take 4 spots and I can show that they relate in these specific ways, I can take 4 distinctions that are in the vicinity of each other in the cause-effect structure, and I can find a mapping between the properties these spots, the way in which they relate, and the relations between these distinctions. So there's not a lot of time, but I just want to point to you that, for instance, reflexivity can be formulated in terms of cause-effect power as the fact that this specific type of substrate, a grid, is such that every distinction specifies a cause and an effect with a self-relation. So you can see, for instance, CDE has a cause over D and an effect over D, and there is a self-relation between the cause and the effect. They are exactly the same. Inclusion can be formulated in terms of cause-effect power as the fact that distinction BCDE, for instance, having the cause and effect over CD, is included by another distinctions, which is BCDEF, that has a cause over CDE and an effect over CDE. And of course, the cause and the effect of BCDE are a subset of the cause and the effect of BCDEF. Likewise, distinction BCDE, just like spot S1, includes another distinction, which is CDE. And you can see why. With the relations in this case, because D is a subset of the purviews of BCDE. You can translate partial overlap or connection in terms of the relations between two distinctions, in this case, BCDE and CDEF. They only partially overlap over D. You can see that the purviews are over CD or BCDE and over DE or CDEF. So you have a partial overlap over D. And then fusion holds, because if you take BCD and CDEF, their union is also a distinction with its cause and effect over CDE. So this is just to tell you, if you look at that diamond there, it kind of looks like this diamond here, right? You can retrieve this sort of pattern of relations that we described in phenomenology in terms of cause-effect power. So now, crucial point is that these holds at the level of 4 little distinctions, but of course, what we said is that this is true throughout the space. All spots that are extended, that feel extended, satisfy all these properties. So if we just take these 4 distinctions now and we represent their relations of reflexivity, inclusion, fusion, and connection in this little diagram, well, now we can ask what happens throughout the structure. And if we unfold the entire grid, we can see that all these distinctions relate with this pattern. So these relations hold throughout the structure. We can retrieve the full space by checking whether reflexivity, inclusion, connection, and fusion hold throughout the structure. Skip that. Okay, one last point that I can make, and we are not going to go into the details of this, is that like James said, the characterization of spatial experience in terms of these essential properties, reflexivity, inclusion, connection, and fusion, is just the beginning. The attempt of the space paper is to capture which properties are essential for space. But then, of course, if you did your microphenomenology approach and you sat down somebody and asked them, tell me about your spatial experience, just spend 10 minutes talking about what it feels like to see the blank screen, they will probably say something like, well, I see a lot of regions, you know, there's like a left side, a right side, and I can focus my attention on a smaller region and a bigger region. So region is a derived property that we have to address. And we can translate, again, formulate this property in terms of cause-effect power, and we can account for the feeling of regions in space. We have to do that in terms of cause-effect structure. Similarly, every spot that I show feels located somewhere in the visual field, right? So location is also a property that phenomenologically we can talk about, and we have to account for that in terms of cause-effect power. And similarly, size, boundary, the distance between spots, these are all properties that we have to account for. And the space paper does a great job in starting from the essential properties, but then showing how you can get all these derived properties really with no additional ingredients by unfolding the distinctions and relations of a grid and just analyzing the relations between the distinctions. You can retrieve these, this mapping. Sure.
I want to make 2 additional points on this, which are perhaps to remind you of why we take it for granted. So you just saw, and Matteo just pointed out that location, a spot located here, okay, or there, whatever you want to call it, is something that we have not the slightest problem in understanding. If I say, look there, that spot is there, everybody understands that, there, okay? Now, what does it mean to be there? To experience something as being there, and that's true for every spot, okay? What is there? And that's where you get stuck for a moment because, oh, it's the coordinates, X, Y. No, why not? It's not that, okay? So the whole idea here, and it can be formalized properly, is that a spot being there that's indicated there as location is actually the supertext, we call it, of a particular distinction. So all the distinctions that relate to that distinction by inclusion, that's called the supertext, is precisely the there-ness of that spot being there. It wouldn't feel there. We like to say there is no here without the theirs, okay? It wouldn't be there if it weren't because you have all those other spots and they're related in that particular way. So when you say it's there and it's the simplest thing in the world, and I give you two spots, and they are one here, okay? And they are at one distance. And I don't mean give me the exact distance. You just experience them as being here and then and you see the distances among all spots at once without having to compute anything. It's just all there. Every spot is at its right place and all they relate in the right way. This is why we don't have to do any effort. We don't have to compute anything. It's so easy. It's right there. It's space that we are so confused. We don't even think it requires an explanation and we cannot understand the kind of explanation. Nobody, and I assure you, no piece of your brain is making a computation that gives you all the theirs and all the distances among the theirs. It's all there for you right away. It's not a computation, it's not a process, it's not a function, it's a structure. That's our claim. It's a structure. It really exists there physically as that structure. You don't have to compute anything. It's what exists. Second point is, I want to remark again, there's when we say, okay, the relations, if you go back to the diamonds, so those are the relations of connection, inclusion, fusion, etc., and they are indicated there. That language is dangerously reminiscent for us of the language you use in mathematics or in everyday language, in which we say, you know, this is related to that, where we point to a relation that is extrinsic. In other words, we say, you know, I think this has something to do with that, and you don't really know what the hell you're talking about. They're related in your mind, you think they're related in the real world, but it's an abstract thing that we predicate on. Here, a relation is physical. So literally, if I do this, I see that, then we check integration, exclusion, and everything, and then I do it for another distinction, and then if they overlap in their effect, for instance, there is a relation. It's as physical as anything. That's all there is in IIT to physical. There is cause-effect power, and the relation is an overlap in cause-effect power among causes, effects, and the like. And either there is such a thing or there isn't. And it's a property of that thing, of that substrate you're studying by observing and manipulating. It's not something we just say, this is related to that because I see a connection among them in my mind. It's really in terms of physical cause-effect power. Okay, so those are, I think, two important points that can, however, only be understood if you follow the entire procedure of IIT. Okay, existence phenomenally is demonstrated to us. It has those properties. We give them a physical formulation where physical is operational, it's distinctions and relations, and ultimately what exists are structures. And space is a structure, not a process, not a computation, not a function.
So if you're interested in this last point, there's a paper we published back in, I don't know, 2022. It's called Of Maps and Grids, where we try to show that you can build two systems that are functionally basically equivalent. They do spatial functions. In this case, there is a sort of artificial eye that performs a fixation function. But you can build this very same system with a layer here of neurons in two ways. One is a grid that if you unfold it has exactly all the spatial, intrinsic spatial properties we just talked about. The other one is what we call a map that doesn't have any lateral connections. And if you unfold this thing, you just have, this is the cause effect structure, the set of cause effect structures actually, because it's not even a system. That thing doesn't exist as one. It doesn't specify any cause effect power that resembles any spatial property, and yet it performs exactly the same functions. So you need all the layers to be there for there be here somewhere, but also you just need a cause effect structure to have spatial qualities and properties. It doesn't matter what the function is. I mean, you can build the same system in this way. You can check.
One thing, thanks, Matteo, for pointing it out. For neuroscientists, now, of course, we don't know for sure here, but to make the point, we are trying to suggest that grids with lateral connection for sure, you find them in the whole posterior cortex, B1, primary cortex, MT, posterior parietal cortex, whatever. Those are grids that have the right anatomy, and unfolded, they would produce something like that, just much, much bigger. But even in our brain, there may be something more like a map system. Okay, that would be what you see there in orange is the nucleus of the olfactory tract. The one we could find that there seems to be little indication of lateral connectivity. So it maps just like the lateral genicular nucleus and primary visual cortex and so on, the retina and therefore the world. And it produces an output, like for instance, eye movements that can pursue objects that are moving also. So it's a good mechanism for doing that. Okay? And if to the extent that it is just a map, so no lateral connection, it does its job perfectly well, but there is nothing it is like to be it, you would say. And indeed, that seems to be corresponding to what neurology would call unconscious vision. There's lots of little clarity there, but unconscious vision that they test your reflexes when you are not responding to anything, but they want to know, do you have a pupillary reflex? Can you do pursuit and things like that? They can tell you if there is some function preserved in the brain. It may be function preserved in the nucleus of the olfactory tract and those circuits. And that's unconscious vision. Whereas the one that obviously supports our sense of space is in cortex. So that's what the evidence says. Okay, so there is potentially mapping even onto our brain. The most important mapping of all, in fact, as we'll discuss probably tonight, is on computers, and including self-navigating cars who can do perfectly well, and functionally they see, and if IT is right, phenomenally they see absolutely nothing. So the language is again not good. Okay, we talk about, is the car that's driving you home avoiding obstacles and explaining to you why it's doing that? Seeing or not? Well, functionally, obviously it is. It does it better than you're driving by now. Phenomenally, if you're right, because it's implemented in a computer, absolutely nothing. There is nothing there. Nobody is feeling anything whatsoever. It's just like that map. It does its job perfectly well. For us, it acts as if it were seeing, but there is no sense of space whatsoever. Though it can talk to you about space perfectly well. Oh, that's to the left, that's the right, that's the distance. If it is good, it does all those things. But there is nothing it is like to be it. So it's a rather provocative statement given that we are being surrounded now more and more by such things.
Yes, I can finish with just one slide. Yeah, and then we can take questions. Okay, so everything we've done for space, you do it for time. That's it. Same thing. No, I'm joking. But just like that. Oh. Okay. Well, okay. Let me say something about this. Maybe you can take the next slide. Okay. So I just want to point out that the template of explanation of IIT is going to be the same for space, for time, for objects and concepts, for colors. So we start by characterizing a subset of our phenomenology, in this case, the experience of the flow of time. We want to find some essential properties. It turns out that time and space are kind of similar to each other. You have the full species present. It feels like a composition of moments instead of spots, and the moments overlap with each other, include each other, but crucially, they are directed. They flow away from you, right? If I do this, kind of feels like the experience goes away before it gets into the past and it's just memory. Then you can find some derived properties. And the point is that we want to do the same thing. We are actually almost done with the paper. If some people are interested, we can talk about that with Renzo. In this case, we had to unfold a different substrate, of course. In this case, it would be directed grids, grids that have a preferential direction of, so the connections are weighted in one direction. This is still a substructure, a different substructure of our cause effect structure, and we should find a correspondence between the properties of temporal experience and the properties of the cause effect structure.
How come, Renzo? Do you feel like you want to explain this figure, or should I do that? I mean, nobody wants to do that. In any case, fine. I mean, let's just let yeah. Okay, so I want to say a few things about this.
Yeah, I'll give it a shot. Should I go? So yeah, I think one of the main messages here is that in IIT you have this dissociation between clock time, right, which is physical time, so the succession of say 10 seconds. So we here show, for example, the presentation of two notes, the blue note and then the pink note. But in IIT, the causal effect structure is unfolded in a single macro grain of time. So here represented this macro update, say 30 milliseconds, and every experience exists within this single grain, and it's unfolded, and within it is where the correspondence to phenomenal time, which we call flow, is found. So the properties that we can identify in temporal experience, here we represent the moments and the way they include in a directed way and they connect in a directed way. We can also find within the unfolded cause effect structure of the directed grids. But the important thing to see is that time, the phenomenal time that we experience, is not a succession of clock time or of cause effect structures or processes or the percolation of activation through the grid. It is found within the cause effect structure as this almost static structure, right? So the now, the now and the then, as we experience, it is within a single, so the experience of, say, extended present, let's say 200 milliseconds or maybe 2 seconds, it's all occurring within a single macro update of 30 milliseconds. So we have this dissociation, and you wanna add?
Well, let's take a question first and then add something.
Yeah. Can you explain why there are 3 dots that are independent from the main structure? Like what does it mean? On the right, like you see that there are. Okay.
Wait.
Yeah. Okay.
Oh yeah.
So,
Yeah.
oh, okay. It's just the picture that is okay. Okay.
Right. No, that's just the problem with the visualization. It's not meaningful. You mean that single distinction that is?
Yeah, it doesn't
divided?
seem structured.
No, yeah, that's just
Yeah. Okay. Great.
yeah.
Okay. Well, I also have another question, if I can, very quickly. So it goes back, but it applies to time as well. So let's say that we have the substrate of time, like the neural correlate of time, and we unfold it, and we find a cause effect structure. And within the cause effect structure, we find a good match for these essential properties of the phenomenology of time. except let's say one, and maybe this doesn't work well with space and time, but just for the sake of argument, let's go with it. That would be that maybe not a complete knockout, but it would be like a bad knockdown for IIT, like, so maybe not a complete falsification, but still would look like something like that, right?
I think more generally, yes. The idea is that there is going to be a one-to-one correspondence between the way it feels and the cause-effect structure supported by the subset of consciousness. Anything that deviates from that would be a big problem for IIT. In essence, it might say that the theory is wrong. Now, as usual, depends on the precision of the data we have, the confidence in the data. Things are always complicated. You just refute a theory with one experiment and many unknowns. But the general idea is, yes, it's not good to, well, this doesn't fit, but maybe there is some other way to do it. It's a very, very radical statement that's made here. And so it has to fit. In the case of space, we won't go through this because we don't have time, but we can maybe when we discuss this. If people want to talk about this in the afternoon, we'll be available, several of us, to discuss these things in more detail. But for space, there is actually neurological evidence and neurophysiological evidence to support this notion. In fact, in a way, it's again trivial. So almost all of neuroscience and neurology before neuroscience started from pointing out that there is what people call a topographic mapping of the world onto the retina, onto the LGN, onto V1, V2, V3. That's the first thing you learn. So different position in visual cortex respond to different position in space out there, which correspond to retina, LGN, and so on and so forth. So that's a mapping. And for that reason, we call the paper of grids and maps. It's presented like a map that maps the world. That's how you go. Space is out there, then you map it. IT is intrinsic. All meaning is intrinsic. Therefore, leaving aside how it came about, which is by interacting with an environment which is structured in a certain way, if you have a grid, which you have after a certain age in V1, V2, and V3, you are going to experience space, whether your eyes are closed or open, whether you are dreaming or not, whether you're imagining or not, it's just going to be extended. There is no way it's going to be like that because that's what exists. What exists is a structure which is called an extension like that. And it happens to go rather well in mapping stuff out there. That's actually how it came about in the first place, because there are correlations that you pick up from the world that get transferred or incorporated as lateral connections, etc. But once it's there, that's what exists. That's the only thing that truly exists. And then you map the world well enough that you can survive in it, so to speak. So that's the idea for that, okay? So that's for space. In reality, it would be for everything else. And in neurology and neurophysiology, you can, for instance, show that if I kill a piece of this grid, half of space is gone, literally. And of course, usually the approach is to say, oh, that's gone because, of course, you can't see that because you don't map it. No, it does not exist in your dreams. It does not exist in your imagination. It's just gone intrinsically. The same is true if you have some scotoma, meaning some lesion in visual cortex that produces blindness. And to this day, there is great confusion in neurology between the fact, and that tells you everything, okay, that people talk about, he has a scotoma, the patient has a scotoma. How do you do that? You map it. What you do, you show stuff all around, and you draw the borders of the part that the patient is blind about. Let's say a quadrantanopsia would be a piece out here that the patient does not see, okay? And that's it, that's a scotoma. And then actually neurologists did get some evidence, but they just didn't conceptualize it usually very clearly, that there are two ways, so to speak, to be blind. One is you are blinded, meaning I can see everything, but somehow I don't see the people there, okay? So I'm blind there. And then I typically also know it. We've got a problem here, okay? The other one is I am intrinsically blind. Or we call it absolute spatial agnosia. But in general, that would mean that, yes, I am also blind. I don't see things there. But that piece of space does not exist for me. It just doesn't exist in my dreams, in my imagination. It does not exist, okay? The blind guy who has a retinal lesion, for instance, or even you, if I put something here, will tell you, I don't see the stuff out there, but the space is there, it's just gray. The guy who doesn't have space, there is no problem, nothing is wrong. It's just like the split brain I told you about, only half of the visual field exists, but they never complain. The split brain patients don't say, oh, suddenly my space has shrunk. They don't even know the other guy exists, so, but they don't complain at all. And so is the case for patients who have this quadrantonopsia, for instance, or immunopsia. They don't know they have a problem. Well, why would they have a problem? That's all there is, okay? So it's critical, and there's plenty of evidence for these things, including some experiment we did a long time ago that should be replicated, and primitive in a way. A prediction of IIT is that if you change the strength of connections within, say, visual cortex, and you leave the activity patterns the same, space should be warped. So if you use tricks like rapid flashing of lights that presumably lead to the strengthening of a connection, but then you stimulate cortex in such a way that you don't really touch those areas, but elsewhere, suddenly the space shrinks. That's because if you unfold the altered substrate where you strengthen some connection, this thing is altered. Okay? So there are all these things. For space, I think there is evidence, which is, some of you may have, and I'll just say it is a good opportunity to say so, read about the Scott Aronson objection to IIT. How many have heard about it? Okay, so several people do, and that's one of the things we often hear, okay, well, what about Scott Aronson, okay? Scott Aronson, many years ago, wrote something in which, Scott Aronson is, a quantum computing guy who is sort of famous as a very famous blog. I mean, he's really smart and good guy, no argument about that. And he wrote an article, this was like 10 years ago by now, in which he praised IIT for being the only theory that what it was mathematical and precise about consciousness, so good. But obviously terribly wrong. I mean, he was getting high marks because at least it could be wrong because it was precise and specific, but it was obviously wrong. Why? Because the implication of IIT was that a grid, he made an argument about expander graph, but he admitted that the main thing was it had to be physical. So a grid of whatever, silicon, and he admitted that it was difficult to make it sort of like the brain with lots of connection, but would be conscious. And he didn't say phase, but conscious, because phi would actually be pretty high. And if you made the grid bigger, it would be even more conscious. But obviously, a grid is such a stupid, simple thing that that theory clearly must be crazy and completely wrong, because how could a grid, such a simple thing, be conscious? Okay, so let's go back. That's a useful thing for this. I wrote immediately a reply to that, which is in essence what the space paper was about, but before the space paper was there. And the point was, yes, this was an IIT from the start. Grids are a very good substrate with certain special properties, not enough to be a grid. And that's a feature, not a bug of the theory. Second, we are grids. So as much as you want to be nonchalant and cavalier about grids, or grids are the simplest thing in the world, most of posterior cortex is fundamentally a bunch of grids with some hierarchy too. Okay, it's not just grids. But most of what seems to be the substrate of consciousness is a bunch of grids or dense lattices of neurons with 10,000 connections, not just 3 or whatever. But that's what you find. And maybe you should consider that evidence as actually supportive of IIT, as opposed to, well, no, my gut feeling tells me, a grid is a simple thing to describe, therefore it's not sufficient. That brings me to the so-called third and fourth problem of space. The first problem was that space, feeling of spatial extendedness, is just as much the hard problem as blue or pink. The second was we don't recognize the richness of phenomenal experience of space. The fact that to feel extended, it must be tons of spots and hypertons of relations of a certain kind among spots. The third problem is, if IIT is right, what corresponds to space, well, this is time, but all right, what corresponds to space must account one-to-one for all these phenomenal properties. So it must be an extraordinary thing too, super rich, so an extraordinary cause-effect structure, where you can find all the properties, the extraordinary rich phenomenology. And finally, that the substrate that unfolded is expressed as that cause-effect structure is the Humboldt grid. In that case, even a 1D grid, okay? By the way, when you unfold, the one that we did with Andrew in the space paper was 8 units 1D. The number of relations was close to 10 to the 40. So that's a 1D grid of 8 binary units connected with lateral connection. You unfold it. There are hundreds of distinctions and a crazy, crazy, crazy number of relations that are physical. So the Humble grid, once you look at it with a qualia scope, as opposed to just saying, oh, I just take this motif and multiply it many times, the algorithmic complexity of the description of the grid is trivial. It is. Once you actually ask what's there physically, assuming physically means you have to unfold all its powers, it's a giant monster. Maybe it's a regular one, but it's a giant, incredible crystal, okay? And there's no computation, no processing, no anything. It's like that. Which brings me to finish at one, now we start, to time, where the main thing about this, given that Matteo and Renzo decided likely not to go through the whole derivation, the properties, etc., and the phenomenology of moments and how they overlap each other in a directed way, and so on and so forth. But it's an exercise similar to the one of space. But the main takeaway at the end is precisely this, is that if IIT is right, what you heard just now, what you heard just now, which is this present, variously estimated to be between 200-300 milliseconds and 2-3 seconds, is still unclear, it may vary. What exists together in your mind, in your consciousness right now, so to speak, that which includes ordering and succession and so on, such that the first word is before the second word and so on and so forth, and the first phoneme is before the second, all of those things that make it feel the way it does, leaving aside the particular sounds or timbre and so on, just like you leave aside colors and so on for space, that feels extended in time and flowing in one direction and fleeing away from it. That's how it feels. That's the most general thing about time. Very much like space, but flowing away from it. Always impossible to catch. You can't catch the moment. It always flees away from you. That is explained by a structure which is absolutely static. So it's unfolding. We think in the brain there must be, this is much less known. We don't really know this. It's a conjecture. It could be wrong. Plenty of these directed grids, in fact, stacks of these in parallel, with a delay line underneath that's the input array, so that you can preserve, so to speak, a trace, very trivially, of let's say 1 second. Here is 220 seconds of activity that in clock time succeeded each other, with some guys on, some guys off, whatever that might be. And that is there right now, where now is 30 milliseconds. We have some reason to estimate something like that. It's a macro grain. We didn't talk about macro. You unfold this particular thing here and now, meaning these 8 neurons, 2 on, these are 7, okay, and 5 off, over a macro grain of 30 milliseconds, and you get this kind of structure that accounts for the way time feels, that is flowing, directed, and all that. And it's a structure, it's another crystal, totally static. And the idea would be, it's a bit extreme if you think about it, that such a structure is born, so to speak, comes into existence every, let's say, picosecond, or whatever the clock of the universe really is, the update of these micro units it can observe and manipulate. Remember the atomism of IIT. So it comes into existence, and that's beautiful structure like that. It feels flowing. And then it vanishes, and another one comes about, and it vanishes. And it vanishes instantaneously. So it's just talking about Buddhist here in Japan impermanence. This is the apogee of impermanence. Every picosecond there's the structure, but it's so ephemeral that is gone. Yes, there is another one, but it's going to be very similar to it, very similar to it, very similar to it for, let's say, 30 milliseconds of clock time. And then maybe it starts changing. That's the macro grain. So you hear some other thing, okay, the next period and so on. So it's a bunch of these beautiful but ephemeral structures that succeed each other in clock time, but all that truly exists is each and every one of them. And within themselves, they contain all there is in terms of present with its now, the very instant at which you hear, and whatever is still contained to make the sentence what it is, or the music what it is. And after that is outside of consciousness. And then within this short window of present, which for us, and it's an interesting empirical question, if we do find these directed lines in the brain and where, et cetera, like auditory cortex, etc., do you find them in animals too? Is it maybe the case that we have a longer line so that we can actually have within and present of experience more stuff, a longer sentence, a longer melody, and that gives us enormous advantages evolutionarily, okay, for instance, something like that. So if we had that, do we find that in animals, or they live in a shorter present, for example? And that would have a neural basis for that. On top of that, I just want to mention it, since it is one, that the other thing, and that has to do with objects and concepts, which is part of the research program, if in this present, we can also recollect memories, including the distant past, and of course, goals in the distant future, then, and only then, do these memories and goals gain true existence. Only when they are, let's put it like that, illuminated by the light of consciousness of this present, which is this giant, beautiful diamond that exists ephemerally, for instance, only then do they truly exist. And that is true for everything, if the position of IIT is correct. It's true for our ideals, it's true for concepts like truth and beauty, it's true of mathematics, it's true of anything. The only thing that truly exists, remember the initial exercise when I said, if everybody were to disappear, the only thing that truly exists are these structures that are maximally reducible within. They exist for themselves intrinsically. They are intrinsic, specific, unitary, definite, and structures like space, like time, like object, like concept, and like beauty.